Good day.
Yeah.
Today we shall look at how we can denoise or foster an image. How we can denoise or foster an image. So, example, I have this image on desktop. This is the image. You can see it's corrupted. Now let's see. Open. Let's open it and then see. Okay, let me enlarge it so that you can see. So you can see the image as what? Corrupted. How do we remove these noise from the corrupted image? So we are going to look at how to do that. Okay, so let's look at this question. The marks obtained by some students in a class test are as follows. So these are the marks that some students took in a class test. Use the above table to estimate the following in the distribution. So we have median, maximum, minimum. Okay, now let's start. Median. When we talk about the median, we are actually looking at the midpoint in the distribution. We want to find a variable or a data that can enable us to split our distribution into two halves. So we will have on our right the highest range of elements, and then on our left we will have for the lower range of or the lowest range of what elements. So that's basically what the median does. It enables us to split the distribution into two halves, that is highest and then the lowest. So how do we estimate the median? So let's see how we can do that. So let me change the font size to maybe 18. So we have our data is what? 1, 4, 3, 2, 2, 5, 5, 4. Sorry, we have 4 and then 5. Okay, so we need to what? Sort these elements in a particular order. If we only want to estimate the median, we need to sort it either in ascending or descending. So how do we do that? So we have 1, 2, 2, 3, 4, 4, and then 5, 5, 5. Yeah, so we have 9 elements. Now, to estimate the median, we need to pick the middle number. So over here, let's look at our middle number. We have 1, 2, 3, 4, 5. Since we have 9 elements, our middle number is what? Is 4. So let's make it red. So our middle number is 4. So our median of the distribution is what? Is 4. We have 4 elements on the left, 4 elements on the right. So our middle number is what? Is 4. So 4 is our middle number. Now, how do we find the maximum? The maximum is actually the highest mark in the distribution or the highest value. So from what? Now let me write median is equal to 4. Then maximum. So who can tell me the maximum? The maximum is basically what? The highest number or the highest mark, which is what? 5. And then the minimum of the distribution is what? Is 1. That's the least mark. So we have even arranged the element in a particular order. So our highest mark is what? Is our highest mark is what? Is 5. And then our middle is what? Our least mark is what? Is 1. Okay. Now we can still use this same technique in image processing. You know, the image that you see is made up of what? Pixels, and these pixels are basically numbers. And because they are numbers, we can apply the statistical operations like the median, the maximum, the minimum, the average to change the behavior of the image. That's basically what is happening here. We can apply these same operations on our image, which is corrupted, to what? To change its behavior. So for example, if I want to represent a black pixel, I need to use an intensity value of what? Of 0. So 0 symbolizes what? Black. It's pure black. So I can do something like this. Let me take a shape and change it. So this is what? This 0, this value 0 represents what? Pure black. What about white? White is being represented with what? 200, a value of 255. So 255 symbolizes white. Now, let me take.
I got no one to worship, so I go bow to your glory. Lord, I got no one to praise, so I go lift up your name.
255 symbolizes white. Now, in between 0 and 255, we can get what? A mixture of what? Black and white. That means the pixel is neither pure black nor what? White. So we can call it grow. Now, we can get something like 128 to represent grow. Let's see how the grow looks like. We have this one. Okay. So you can see that this is what? Neither pure black nor what? White, but it's a mixture of what? Black and then white. So we can get an intensity value of what? 128 to represent what? Pure, to represent grow. Now, let's try and then build our denoising algorithm. That is our algorithm to filter the image. Okay, we don't want to waste so much time. So let's assume we'll create another assumption here. Okay. So we assume that this is our image. This is an image. And for this particular image, you can see that the borders, that's the boundaries, are what? Are all 0. So you can see we have 0 here, 0. The boundaries are what? Are 0. So this is 0, this is 0, and then we have what? Zeros. This is also what? 0. So our boundaries are what? Zeros. Then our inner portion is what? Is made up of what? A mixture of what? Black and then what? White. You can see 9 here will not give you pure black. There will be some white element. 5 will not give you pure black. So that's basically what is happening here. So now we want to filter this image. We assume that this image is corrupted, so we want to filter this image. How do we filter this image? First of all, we need to create a template. So we'll create a 3x3 template. Okay, so 3 rows, 3 columns. Sorry, let me bring it here. So we create a template. So we have 3 rows, 1, 2, and then 3. So we have 3 rows and then 1, 2, 3. These are the columns. Okay, so what we are going to do is we will place this kernel over this image. That is, we will superimpose the kernel over the image. Okay, so when we lift this kernel and then place it over the image, we are going to get something like this. Okay, so let's shape. So we have left this kernel over here. So we have how many elements here in the kernel? So we have 9 elements. Now we need to what? Sort these elements and then pick the middle value. So the middle value corresponds to what? Our positive pixel. Okay, so we have 0, 0, 0, 0, 5, 0, 0, 0, 3. Okay, so we have 6 zeros. 1, 2, 3, 4, 5, 6. Okay, 6, 7. Sorry, our zeros are 7. So 7 zeros, we have 3 and then 5. So we've sorted this element. Now, what is our middle value? Is what? Is 0. Now let's count. 1, 2, 3, 4, 5. So our middle value is what? Let's make it right. Is 0. Now, let's construct another table. So
Lord, if you know, Father, if you know, I said if you know,
okay. The value that we calculated, the median value that we calculated is for this particular cell, the first cell. So we are going to place it here, 0. Please, are you following? The median value that we calculated is for this particular cell, the first one. So we place it here, 0. Now, we will move the kernel by 1 step to the right. We will move the kernel by 1 step to the right. So this kernel will come here.
Mr. Harry, it's the it's 1515 every go. Oh, on this one.
So we'll move it by 1 step to the right. So we'll get, it will be like this.
He know they give me pressure. He they cool down me. Do I go call on your name? Lord, if you know.
Okay.
If you know.
So what we are going to do this time is to solve our element. So we have zeros. So let's count the zeros. 1, 2, 3, 4, 5, 6. So we have 6 zeros. 1, 2, 3, 4, 5, 7. And then we have 3, 4, and then 5. So what is our middle? We have already sorted the element in this cell, the 9 cells. So our middle number is what? Is 0. So this one, our middle value is what? Is 0. We move the kernel again by 1 step.
You the show and power initiator. I said you need a sleep no slumber. You the watch over my life like a watchman. Whenever there was strike like a thunder. You the show and power initiator. It told me not to fear, cause me now I'm in a copy ball.
Okay, so
oh, I got no one to praise, so I go lift up your name. I got no one to worship, so I go bow to your glory. Lord, I got no one to praise, so I go lift up your name. I got no one to worship, but you alone, yeah. If you know.
So let's
Lord,
change the border.
You know. Father, if you know.
Okay, so we have moved the kernel by what? By 1 step. Now let's calculate the median of the cells.
Where you got me, Lord, if you know. You got my questions, Father, if you know.
So we have how many zeros? 1, 2, 3, 4, 5. So we have 5 zeros. 1, 2, 3, 4, 5. Then we have what? 1, 3, 4, and then 5, and 5. So what is our middle number? Is 0. So our middle value over here too is 0. So when we finish, when we get to the extreme pixel, we will, or after computing the pixel value at the latter part or at the extreme position, we will move the kernel one step downwards. We'll move the kernel one step down. That is when we get to the last column, we will shift the kernel one step downwards. Okay, so let's shift the kernel one step downwards and see what we will get. Okay.
You got my questions, Father, if you know. Where you got me, I said if you know.
Okay. So the kernel will be placed here. That is after computing for this particular cell value. The kernel will be placed here. Okay, so
yeah. Oh, na, na, na. Hey, yo! Mr. Harry.
We'll move it one step downward. So let's calculate the intensity value. Let's calculate the median value. My mouse is not working to my satisfaction. So we have 1, 2, 3, 4, 5. So we have 5 zeros again. 1, 2, 3, 4, 5. And then we have what? 1, 2, 3, 5. Okay. So what's our median value? Our median value is what? Is 0, which is this mark. So our median is what? 0. So this one will come here. Please, do you understand whatever we are doing? So we are going to move this kernel over all the pixels in the image. The final pixels that we get represent our what? 4Z image. So after computing the median value of all the pixels, we'll bring these median values together, which represent our denoised image. So the values in this cell, all the values that we will generate for this particular image corresponds to our 4Z image. So first of all, we take a kernel, 3x3 kernel, and then we will move this kernel over all the pixels in the image. The values that we will get for the pixels corresponds to our 4Z image, or the median value that we will get corresponds to our 4Z image. So this is basically the algorithm. So let's check if the algorithm is working or it's not working. Now let's open Matlab. So first, please, if you are interested in some of these things, try and then download Matlab. It's not a free application. You need to buy it. I'll put the link to where you can get Matlab to buy. So let's open Matlab. Okay. So we want to create a file. So save as let's call the file denoise. Okay, save. Now we need to hold at this particular moment. We need to read our corrupted image into Matlab. So we create a variable, let's call it image1 is equal to mread. This is the function that we use to read an image into Matlab. mread. Then we specify the path. Don't forget the strings. We specify the path What is the path? Right now I'm in Matlab folder, so I only need to specify the name of the image, and the name of the image is noisy.jpg. jpg is the extension. Then I close my brackets, semicolon, to terminate the statement. So I've terminated this statement. I press enter. Now I want to verify if I have read the correct image, so I need to display the image. So in show, we use this command to display image onto the screen. So in show, then we specify the name of the image, but you see this variable image1 is holding this image, so we specify the variable holding the image, that is image1. That's the image1 is just a variable name. You can name it anyhow or any way that you want it. So enter. Now let's run it. So we use the run command. Let's run it and see. Okay, so you can see that I've read the right image. You can see this image is what? The image is corrupted. You can see for yourself that the image is corrupted. Okay, now I want to what? Filter the image. There are two ways of doing that. The process that we went through, you can convert this process into what? Into a form that the computer will understand, or the Matlab application will understand. That is programming. We can translate the logic that we use to what? To filter the image in a form that Matlab will understand. Another way too is that somebody has already taken his time to do all these things. So why do you spend so much time to repeat the same task? We can just call the function into our program. So it's just a function somebody has created. We can call this function into our program, and then it will do the same work for us. So let's see how we can call the function. So let's open Google. Okay, Google. Now, so you type Matlab plus median filter. Let me type it to Matlab plus median filter. Okay. Now I have so many pages. Let me open this one. So it's loading. Okay, so this is the algorithm or the function that does the filtering. So we have this function med_2, that's the median filter. Okay, so the name of the function is what? Median filter. So let me copy this function. Okay, so what we are going to do is that now I need to create a variable that is going to hold our denoised image. That is our filtered image. So we have denoised1. This is just a name of a variable, to hold our filtered image. So denoised1 is equal to then the function that I copied, which is med_2 function. Then bracket. Okay, so let's see. So we have a bracket. Then the I corresponds to the image that you want to filter. So let's write that one. So our image. So image1 is a variable holding our what? Denoised, holding our corrupted image. So I will specify image1. Then comma, there is comma. If you think I'm lying, just check. There is comma here. Okay. Then let's go back. We have array. We have M and then N. The M and N symbolizes rows and columns. So how many rows, how many columns do you want to generate for the kernel? So it's talking about the kernel rows and then columns. So we use 3 rows and 3 columns. So we bring this one, 3 rows, 3 columns. Okay, then we close it. we terminate the statement. That is all. So let's show the results. We want to verify if the algorithm has been able to filter it or noise. So in show denoise 1, so we have passed the variable that is holding our filtered image. That is denoise 1. Terminate. We have ended the statement with semicolon. Now let's run it and see. Okay, so you can see that our image has been filtered. You can see noise has been removed from the image, but I'm not happy with the output. You can see there are some small noise. Let's expand it. You can see there are some small noise. These noise are called salt and pepper or uniform noise. There are some noise in the image, so I'm not happy with the result. How do I rectify that? What I'll do is that I can still change the kernel size. Don't forget that I use 3 by 3. Now I want to change it to 7 by 7. So in all, I'm going to have 49 elements. So my algorithm is going to pick the 25th element. That is the middle number. Okay. So we have 7 by 7 kernel. Let's run it and see the output. So run. You can see that the output of this one is far better. You can see the output of this one is far better. Okay, let me close it. Now what I want to do is I want to display the corrupted image and then the filtered image at the same time. I want to display the corrupted image and then the filtered image. So I call another function figure. I terminate it. So this figure is going to, so over here we are going to see the first image. Then this figure is going to allow the second image to appear at the same time. It's going to allow the second image to appear instead of the first window to close, for the second window to open. It's going to display the two windows having our corrupted and then the noise image at the same time. So let's run it and see. Okay, so you can see the two windows are appearing at the same time. Okay, so this is our so you can see we have our corrupted image and then our denoised image. So you can see that this image has been filtered. So this is our corrupted image. This is our denoised image. I hope you have enjoyed this video. See you same time next week. Bye bye.
Real life telling. Brackle.